Okay, let's unpack this. So imagine you're the CEO of one of the absolute titans of the tech industry. You wake up, grab your coffee, check the markets, and you just see a sea of red.
Not the best way to start a Tuesday.
Definitely not. And the reason for the panic? A Chinese startup, DeepSeek, just released an AI model that basically does what your billion-dollar model does, but for a fraction of the cost. I mean, pennies on the dollar.
It was a massive shock. The market immediately screamed, race to the bottom. The thinking was, if AI becomes this cheap to build, profit margins are just going to vanish. It becomes a commodity.
Right, like rice or copper. So tech stocks took a nosedive. Investors were freaking out. But then in the middle of all this, Satya Nadella, the CEO of Microsoft, he jumps on social media.
Yeah.
And he doesn't post a press release. He doesn't post some defensive chart. He posts a link to a Wikipedia page.
And not just any page. He points to a 160-year-old economic theory about coal mining in Victorian England.
Which is a choice.
It is a serious power move. He's referencing the Jevons paradox.
And that is our mission for this deep dive. We're going to look at this kind of obscure 19th century idea to figure out, is Nadella right? Is he just trying to calm down jittery investors? Or is there an actual mechanism here that suggests cheap AI is going to make these companies more money, not less?
It's the multi-billion-dollar question. Because if Nadella is right, the market has this completely backwards. He's betting that efficiency is actually the rocket fuel for consumption.
But to understand that bet, we have to go back to the source. And honestly, the source material you sent over is surprisingly bleak. We're going back to 1865.
1865, the height of the Industrial Revolution in England. And the mood isn't optimistic. It's actually bordering on terrified.
Because of coal.
Because of coal. You have to understand, at this time, coal wasn't just a fuel source. It was the source. The entire British Empire was built on this combustible black rock. It powered everything.
And the panic was that they were going to run out?
That was the fear. Leaders were looking at the consumption rates, doing the math, and realizing the mines were going to go dry. And the belief was that when the coal stops, the empire stops. It was a genuine existential crisis.
Okay, so enter our protagonist, William Stanley Jevons.
Jevons is such a fascinating character. He was young, only in his late 20s, and he was a pioneer in using, heavy statistics and economics. He was crunching data, not just philosophizing. He looks at this coal panic, and he writes a book called The Coal Question.
And this book becomes a bestseller because it challenges the one hope everyone was clinging to, right?
Exactly right. The common wisdom, the hope, was technology. People thought, okay, sure, coal is finite, but our engineers, they're building better steam engines, more efficient furnaces, so they'll use less coal to do the same work. We'll save coal, and we won't run out as fast.
Which feels logical. I mean, if I buy a car that gets better gas mileage, I buy less gas.
Yeah.
It just seems like common sense.
That is the intuition. But Jevons argued that this intuition was, and this is a quote, wholly a confusion of ideas. He argued the exact opposite.
He thought efficiency would burn more coal.
He didn't just think it, he proved it with the numbers. His logic hinged on something economists call elasticity.
Okay, let's break that down. Elasticity.
Think about it this way. When you make a steam engine more efficient, say getting more power out of a lump of coal, you are effectively lowering the cost of that power. Energy becomes cheaper.
Okay, I follow. Efficient engine equals cheaper power.
Now, if the cost of power drops, do you just do the same amount of work and, pocket the savings?
Well, if I'm a business owner in 1865, probably not. I'd probably look for ways to use that cheap power to make more stuff.
Bingo! Jevons looked at the history of the steam engine itself. The very first engines were, they were terrible, inefficient beasts. You could basically only use them for one thing, pumping water out of coal mines. They were just too expensive to run for anything else.
So they were a very niche product.
Totally niche. But then James Watt comes along. He improves the design. Suddenly the engine is way more efficient. It produces power for a fraction of the coal. Now, did the mine owners say, great, let's just pump the same amount of water and save some coal?
No, the sources say they started using them for everything.
They put them in cotton mills, they put them on ships, they put them on wheels to create locomotives. Jevons wrote that this efficiency allowed them to literally draw rivers from the mines.
So the efficiency didn't just save money on existing tasks. It unlocked entirely new,
Entirely new categories of tasks. That is the key. The demand for energy was elastic. It stretched. As the price dropped, the demand expanded massively because people found new uses for it.
And he saw this with iron too, right? The blast furnaces.
Same exact story. New innovations made the furnaces use less coal to make a ton of iron. That made iron cheaper. So did people just make the same amount of iron? No, they started using it for bridges, for buildings, for the hulls of ships. The industry built more furnaces, so total coal consumption went through the roof.
That is the paradox.
Yeah.
Efficiency acts like a price cut, which stimulates demand so much that it just wipes out the savings.
It creates a rebound. And for a long, long time, this was just sort of an interesting historical observation. But it came roaring back into relevance in the 1970s.
During the oil crisis.
Right. Suddenly, the world is facing a new shortage. You've got lines at the gas station, prices are spiking, the environmental movement is born, and the government solution is efficiency.
Mandating better gas mileage, better insulation, better light bulbs.
Exactly. The goal was to save oil and save the planet. But economists dusted off Jevons' old book and asked, wait a minute, is this actually going to work, or are we just making it cheaper to pollute?
This is what you call the rebound effect in the notes.
Yes. The rebound effect is the modern term for it. It's the idea that some, or maybe even all, of the savings from efficiency get rebounded back into more consumption.
There's a great example in the reading from a New Yorker article, talks about refrigerators. And honestly, this one really clicked for me.
The fridge example is perfect because it shows how subtle this can be. I mean, a modern fridge uses a tiny fraction of the electricity of a 1950s model. The engineering progress is just miraculous.
So if Jevons was wrong, our total energy usage for cooling should have plummeted.
But it didn't. Think about how we live now compared to the 50s. Back then, a family had one small fridge in the kitchen. That was it.
Right now, I have the main fridge, which is massive. My parents have what they call a beer fridge in the garage.
Exactly. We have mini fridges in hotel rooms, wine coolers, and it goes beyond the home. The article points out that gas stations now have aisles and aisles of refrigerated glass doors. They're cooling drinks 24/7, just in case someone walks in.
Which they would never do if electricity was super expensive.
No way. It wouldn't be profitable. And it changes the whole supply chain. Because refrigeration is cheap, we can ship avocados halfway across the world. We buy more food than we need because it keeps longer, which actually leads to more food waste, another energy cost.
So the efficiency of that one little compressor in the fridge made cooling so cheap that we just saturated our lives with it.
And as a result, the entire system consumes massive amounts of energy, even though the individual machine is efficient.
Okay, but I have to push back a little here. This sounds like a doom loop. Does this mean efficiency always leads to more consumption? Because I bought LED bulbs for my house and my bill went down. I didn't start leaving the lights on all night just because it was cheaper. I didn't install stadium lighting in my backyard, you know.
That is a crucial distinction, and the skeptics really hammer this point. You have economists like Tim Harford who argue that the extreme Jevons paradox, where consumption totally explodes, doesn't always happen. It depends on the market.
Harford talks about mature economies, right?
Yes. In a mature economy, we often hit a saturation point. There is a limit to how much light you actually need in your house. Once every room is lit, you don't buy 10 more lamps just because they're efficient. In that case, demand is inelastic.
So the price drops, but my usage stays about the same.
Right. Harford points out that in the UK, energy consumption per person has actually fallen by about a third in recent years. We have better cars, better bulbs, and we're actually using less energy. So the rebound effect is real. We might drive a little more, but it's not always 100%.
So it's not some universal law of physics. It's a question of market behavior.
Exactly. And that brings us right back to Satya Nadella and AI.
Because Nadella is placing a massive bet on which side of this line AI falls on.
He is betting that the demand for intelligence is highly elastic. He believes we are in the 1860s coal phase, not the 2020s light bulb phase.
So he thinks we are nowhere near the saturation point for intelligence.
Not even close. His argument is that right now, AI is expensive, it's computationally heavy, we treat it like those early steam engines, we use it for specific high-value tasks, coding, maybe writing some marketing copy.
But if DeepSeek or Microsoft makes it cheap, like practically free, what happens then?
If the cost of intelligence drops to near zero, Nadella thinks we will embed it in everything. It won't just be a chat bot. Your fridge will talk to your calendar. Every single email will be pre-read and summarized by an agent.
I saw someone mention video games where every character has a unique personality generated on the fly. Or drug discovery, running millions of simulations just because you can.
Exactly. The logic is, don't worry about the profit margin per unit dropping. The sheer volume of usage is going to be so astronomically high that the total revenue will be bigger than ever. We will draw rivers of intelligence from the server farms.
That's a compelling argument for investors. We aren't losing margins, we're building a new world. But there is another side to this that I want to dig into. Because when we talk about efficiency in AI, we're not just talking about consuming electricity. We are often talking about automating human labor.
And this is where the anxiety really sets in. It's one thing to say we'll consume more coal. It's another to say we'll consume less human effort.
I was reading the work of Eric Brynjolfsson on this. He's an economist at Stanford. And he tried to apply the Jevons paradox specifically to the job market.
It's the big fear, right? If AI lets one person do the work of 10, the simple math suggests companies will just fire the other 9.
But Brynjolfsson argues it's not that simple. He uses this great analogy to explain it, the pilot versus the farmer.
This is a brilliant framework. Let's start with the pilot.
Okay.
Think about the transition from propeller planes to jet engines. Before jets, flying was slow, it was expensive, a pilot couldn't move that many people per hour. Then jets arrive. Suddenly, a single pilot is moving hundreds of people at 500 miles per hour. Their productivity just skyrocketed.
So, strictly speaking, you needed fewer pilot hours to move the same number of people. If demand was static, airlines should have fired half their pilots.
But they didn't, because the efficiency made ticket prices crash. And because tickets were cheaper, people said, hey, let's go to Hawaii for vacation. Let's fly home for Thanksgiving. Demand for air travel was elastic. It exploded.
So we ended up hiring more pilots, not fewer.
That's the good Jevons paradox in the labor market. Efficiency leads to lower prices, which leads to massive demand, which leads to more jobs. And the hope is that AI does this for, say, software developers or graphic designers.
Right. If coding becomes 10 times faster, maybe we don't fire coders. Maybe we just build 10 times more software. Maybe every local bakery gets a custom app. We solve problems we simply couldn't afford to solve before.
That sounds great. That's the techno-optimist view. But then there's the farmer.
The farmer is a scary one.
In 1900, about 40% of the entire U.S. workforce was in agriculture. Today, it's less than 2%.
And that wasn't because we stopped eating.
No, the population grew. But technology, tractors, fertilizers, combines made farmers exponentially more productive. A single farmer could feed thousands. But here is the catch. Unlike air travel, the demand for food is inelastic.
Because there's a limit to how much a person can eat.
Exactly. Even if food gets dirt cheap, you're not going to eat 10 dinners a night. You're not buying 50 loaves of bread just because they're on sale. So when productivity went up, prices dropped, but demand stayed relatively flat.
And the result was millions of jobs just vanished from that sector.
They had to go somewhere else. They went to factories, then to offices. But for the farming sector itself, the Jevons paradox failed to save those jobs. Efficiency just meant fewer workers.
So the million-dollar question for anyone listening is your job more like a pilot or more like a farmer?
That is the question. Is there a massive, latent, unmet demand for what you do? If you're a lawyer and legal services become 90% cheaper, does the world suddenly consume 10 times more legal contracts?
I mean, maybe. Maybe small businesses that could never afford a lawyer before finally start using one.
That's the pilot scenario. But if you're, say, a translator, and AI can translate instantly for free,
Yeah.
do we need humans to do 10 times more translations? Or do we just let the machine do it?
It's uncomfortable because we don't really know the answer until we see the market react. Brynjolfsson calls himself a techno-optimist, doesn't he?
He does. He points out that historically we've always found new things to do. When the farmers lost their jobs, they didn't just sit around forever. The economy evolved. We invented entirely new categories of work.
Spreadsheets are a good example. They automated the work of thousands of human calculators. But we have more accountants now than ever because they do higher-level analysis.
Right. But the transition is painful. Jevons himself saw this back in 1865. He wrote that machinery throws laborers out of employment for the moment, but eventually widens the field. He recognized that the eventually can take a generation. It can be a very long, hard road.
It's a wild ride. We started with a Chinese AI chatbot, went through Victorian coal mines, checked the fridge, flew a jet, and ended up on a farm.
And there is one final layer of irony here that I think is important to mention, considering where we started.
What's that?
William Stanley Jevons was wrong.
Wrong about the paradox?
No, the math was right. Efficiency does drive consumption. But his prediction was wrong. He predicted that England was doomed. He told the government to prepare for the end of the empire because the coal would run out.
But England didn't collapse.
Oh. Because they found alternatives. They switched to oil, they developed nuclear power, they found natural gas. Jevons was so focused on the efficiency of the current resource that he missed the possibility of innovation changing the game entirely.
So he was right about the mechanism, the consumption trap, but wrong about the apocalypse.
Exactly. Human ingenuity found a way around the resource constraint.
I guess the lesson for us watching this AI revolution is that we need to look past the immediate panic. When you see stock prices drop because tech is getting cheap, that might not be a sign of failure. It might be the starter pistol for the Jevons paradox.
If AI is the new coal, we aren't about to use less of it. We're about to burn it in quantities we can't even imagine yet.
Which leaves me with one final thought to chew on.
Yeah.
Jevons worried we would consume the Earth to death because energy was too cheap. If intelligence becomes too cheap, is it possible to consume too much of it?
What do you mean by that?
Well, if I can generate 1,000 emails, or 1 million songs, or 1 billion lines of code for free, we're creating value. Or are we just polluting the world with noise because the fuel doesn't cost anything? Jevons worried about running out of coal. Maybe we should worry about drowning in content.
That is a very real risk. The spam filter of the future is going to have to be a lot stronger than the one we have today.
Something to think about. Thanks for diving deep with us. We'll see you on the next one.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.